these, what's different about these is that now it's giving you a percentage first. And so then we're going to have to work backwards and find the z-score or the actual score. Okay, so this is a little bit different from what we have done before. And I kind of explain this in a weird way. I don't know, I can't come up with a better term to explain this. But if you are looking for the bottom 25%, think about the fact that that means we are looking somewhere down here for this area down here, right? And that's the way our table is set up, is from a particular point and lower. So if we're looking for the bottom 25%, we know whatever we find here in the table, that's what we're going to go with. But the key is realizing that what we're looking for, the 25%, we have to look in what I refer to as the meat of the table. So we're going to look like where the shading is and where all of the big long digits are. And we are looking for as close to 25% as we can get. So we're looking for as close to 0.25 as we can get. We know it's going to be over on the left-hand side because the negative side, because we know this has to be less than where the mean is, which is at 50%. So if it's the bottom 25%, we know it has to be down here somewhere, but we're looking for as close to 0.2500 as we can get. So the z-score, what do you think? It's like right in between, isn't it? So 0.2514 I'm seeing and 0.2483. So technically that 0.2514 is a little bit, not much, but a little bit closer. So what that bottom 25% is saying is that I want to use a z-score of negative, now I lost my place. What is it? Negative 0.67. Negative 0.67. So that's 2/3 basically of a standard deviation below the mean. Okay? All right. So that's our z-score. Do you see that? So we worked from the inside of the table out to get our z-score. And now we're actually supposed to find the actual score, which means observation, right? So we're going to plug in and say negative 0.67 is equal to amount we don't know, our observation, minus our mean, which in this case our mean was 100 and standard deviation was 6. So we're working backwards here on this part also, aren't we? We're going to multiply 6 times the negative 0.67. We're going to add the 100, and actually I used a different number there. I used a negative 0.675 in my calculation. So can someone grab calculator? What do we get here? Landon, can you check that for me? So 6 times negative 0.67 and then plus 100 to solve for x, right? And what did we get? 95.9? 95.98? Okay, yeah, okay. Mine was pretty close. I had 95.95, but I just wanted to be sure. Okay, so 95.98, that would be the actual score that would need to happen in order to be in the bottom 25%. That's the same thing as the 25th percentile, right? Okay, let's try this other one. Think about this. This is saying top 10%, which we need to figure out what that would really imply here. So top 10%, I need you to think about and realize really that's at the 90th percentile. So you subtract from 100, right, to get to that. So we're doing 100 minus the 10. So we're looking for as close to the 90% as we can get. And we know for that one, we know we have to be somewhere way up here, right, in order to get the top, the 90th percentile. So let's see. I would say 1.28 is pretty darn close, right? Take a look at that. That's 0.8997. So that is closer than the 1.29. So we're going to stick with the 1.28. Does that make sense, I hope? Okay, so we're saying 1.28, that's our z-score, is equal to some amount we don't know, our observation, yikes, minus mean all over standard deviation. When we go do that math, we get 107.68.
If we used like a different number that was like really close, would that be okay?
What?
Like for like the other one, when you used the different one that we did. Like on
What I did on that other one, that's a good question. What I did on the other one is that like this is more or less right in the middle, right? This is 14, at the negative 0.67, we're 14 away. At the negative 0.68, we are how much away? We're 17 away, so that's really close. So I was looking at, okay, halfway in between. So on my paper, when I wrote this out, I did negative 0.675. So I added one more decimal there. Do you see what I mean?
Yeah.
To kind of say it's halfway in between those. But I would prefer that you stick with just 2 decimals after for your z-score. But that's a good question. So let's stick with the 2 numbers after for the z-score. Okay, so that's kind of a backwards way of working these. These are like I referred to it. When you are given a percent, you're going to go to the meat of the table first, and then you can move out in either direction to find what your corresponding z-score is. Okay? I want to show you just a couple of examples of that back page. The wording is a little bit different and the way it's written, and so that throws some people. Let's take a look at that. So it says shade and find the area with the following conditions. I'm going to skip that first one. I want to go to the second one because it's a greater than, and I know that throws some people. So this is saying greater than a z-score of negative 0.73. So let's think about a negative 0.73 means we are almost 3/4 of a standard deviation below the mean. So that's at this particular spot on our curve, right? And if we're looking for the area that is from there and greater, then that's this right here that we want to look at, right? Does that make sense? So in order to find that, because of the greater than, that means we're going to look for the corresponding percentage on our table. So negative 0.73, and that's 0.2327. But because of the greater than, we're doing 1 minus that. So what does that give us? 0.7673. Okay, does that hopefully make sense? So that's for greater than negative 0.73. I skipped that first one. Let's do a between. And then notice these are not written in words, it's just saying greater than negative 0.27. So you would do a similar process for this one as you would here. Let's do one that's between. I like this one better because it's different numbers. So let's draw our three little hash marks there. Negative 0.35 means we're about 1/3 of the way down there. And 1.89 means we're almost up to 2 standard deviations. So this is what we are shading. And how are we going to find that area? What are we going to do? What are the numbers we're going to use? 1.89 corresponds to what? 0.9706, and then minus negative 0.35. Where is that? 0.3632. Okay, and that's what we're subtracting. So 6 minus 2 is 4, 7, 0, so 0.6704. Make sense? I hope? Okay.
So you just find the percentage and then subtract.
Find those percentages and then subtract. Yep. So this is just, you're doing the exact same process as you've been doing here, but it's written in a little bit different format. So that's what I wanted you to become familiar with. All right, 2 worksheets that I'm going to get you for homework. And so, Landon, I need to make sure I get those to you, but I need you to, before you go, I need to talk to you about